Oh, is Henry giving me the thumbs up? It's the wait. Oh, you're putting it live? Oh, thank you. It's nice. The many millions who are dialing in. Okay, we got a few minutes to everyone if we have to. Yeah, is there a... Yeah, I'll just look at my watch. There's no clock, but it's okay. Yeah, good idea. We good? We're live. There we go. Perfect. Thank you. Right, we're off. Okay, good afternoon, everybody, and thank you for joining this panel session this afternoon. I'm very grateful to the IAEA for hosting us, and we're here to discuss the Global Labs Alliance and the role that laboratories, national laboratories around the world can play in helping us understand how to better integrate energy systems and how we can collaborate together in order to progress faster than we perhaps might if we were doing it individually or in our own countries. I'm joined by a distinguished panel today, and you will hear more from them as we go through the session. But first, I'd like to invite Craig Jansen from the IAE to say a few words, and then we'll get into the session itself. Craig, the floor's yours.
Thank you, James. So my name is Craig Jansen. I'm a climate advisor at the International Atomic Energy Agency, and it's my great pleasure to welcome you to an event organised by the UK Nuclear National Laboratory here at the Atoms for Climate Pavilion at COP27. So NNL are focused on a new initiative bringing together several national laboratories working on integrated energy systems planning, modelling. So why is that relevant for COP27? Well, we know the energy system is responsible for around 2/3 of the global greenhouse gas emissions. So decarbonising energy is key to meeting the goals of the Paris Climate Agreement, and in particular reaching the objective of net zero energy systems by the middle of the century or thereafter. The political pledges for net zero are there from a large number of developed and developing countries around the world. But how do we reach that objective? For each country, it will have its own pathway based on its current energy mix, its energy policies, and available resources. So low carbon technologies exist today: wind, solar, hydro, and of course, nuclear power. Advances in these technologies are being made. For instance, in the nuclear sector, small modular reactors and advanced reactors that can help decarbonize beyond electricity. So it is of great importance to be able to model these possible pathways to inform policymakers of the different options at hand. This is precisely the role of integrated energy planning. The IEA has a long history of providing capacity building in energy planning to its member states. Its suite of energy planning and modelling tools have been provided to over 150 member states and 20 international and regional organisations. Increasingly, the agency is getting requests to help member states develop pathways to net zero energy systems. We are providing support to the Net Zero World Initiative, launched last year at COP26 by the United States. And earlier this year, in April, we co-organized with the Argonne National Laboratory an event that brought together different modeling tools. Last week, in the opening event of this Atoms for Climate Pavilion, my Director General, Raphael Grossi, announced an initiative, Atoms for Net Zero, which aims precisely at this objective. The Atoms for Net Zero initiative will help countries assess the potential of innovative nuclear technologies, including SMRs and advanced reactors, as potential contributors to their long-term strategies to decarbonize the electricity and other carbon-intensive industries. The initiative will develop credible scenarios through the IAEA's analytical tool MESSAGE, or Model for Energy Supply System Alternatives and their general environmental impacts. Of particular interest will be a focus on decarbonisation of hard-to-abate sectors, where nuclear, for instance, SMRs and other advanced reactors, can provide a valuable contribution. So, we very much welcome the initiative launched by NNL and look forward to hearing more. There are some obvious synergies and areas of collaboration that can be found and need to be found, because let's be honest, getting to net zero will be extremely challenging, and this will require all possible low-carbon technologies. So thank you very much, and I'll hand the floor back over to NNL and James Murphy. Thank you.
Thank you, Craig. Now it gives me a great pleasure to invite to the podium Paul Kearns from Argonne National Laboratory, who's going to give us a keynote speech for the next few minutes. Thank you. Paul, the floor's yours.
Yeah, thank you very much, James, and I also want to say thank you, Craig, for your remarks. Very much appreciate the context setting and certainly the support and sponsorship of the IAEA, so thank you. So let me say thank you to the audience as well for inviting me really to address this collaboration session. I am Paul Kearns. I have the honor and the privilege really of serving as the director of Argonne National Laboratory. I'm also a former chair and current member of the U.S. Department of Energy's National Laboratory Directors Council. I must also admit that I had some engagement with the National Nuclear Laboratory in the UK during its establishment, and it's really encouraging to see really its success and the impact that the National Nuclear Laboratory is delivering. The Department of Energy, the U.S. Department of Energy National Laboratories have a proud history of leading energy innovation, certainly across the world, and I'm pleased to speak with you on our recent work to leverage nuclear energy alongside renewables for climate change solutions. As Greg indicated, there's really a tremendous opportunity here. I think you'll see quite a bit of synergy from activities going on within the National Nuclear Laboratory, but also other laboratories around the world. And so looking forward to really strengthening our collaboration through conversations such as these. Several of the national laboratories in the U.S. were established at the dawn of the atomic age. Our founding missions were to explore the numerous applications of nuclear science and technology. In total, the U.S. has 17 national laboratories working at the frontier of applied and basic science with unmatched energy and technology expertise, research facilities, and computational capabilities. We are dedicated to the advancement of clean energy technologies. Our nuclear R&D efforts span fundamental reactor physics, thermal hydraulics, material science, advanced reactor coolant technology, radiochemistry, radiation testing, engineering design, diagnostic imaging, and computational science. This summit embodies a pioneering spirit to integrate renewable power with traditional energy sources. We've come together to discuss the challenges and opportunities of achieving decarbonization goals using integrated systems that could apply advanced nuclear energy and renewables. It is our chance to explore technology innovations and next-generation advancements that could be available commercially within this decade. The United States has set an ambitious goal of carbon-free electricity by 2035 and economy-wide net zero emissions by 2050. To reach these milestones, industry and government, along with the national laboratories, are applying a wide range of innovative technologies, including integrated energy systems. These kinds of power plants leverage multiple energy sources to meet a variety of energy demands. They enhance power grid reliability and resilience, and they help stabilize the grid through flexible operation. These improvements will make clean energy systems more competitive by combining advanced nuclear technology, renewable energy, and energy storage. A broad set of national laboratories are exploring this exciting idea, and each has a role to play in achieving the global clean energy mission. Nuclear energy is certainly a key part of this effort. Currently, nuclear power plants generate 19% of the electricity in the U.S. and 10% worldwide. That's 50% of the U.S. carbon-free electricity and just under 30% of the global carbon-free electricity. Ideally, nuclear energy complements renewable energy by providing a consistent and resilient source of carbon-free energy that can support both electricity and heat demands. And it offers high energy density and zero emissions, resulting in considerably smaller environmental footprint than other energy sources. Nuclear is critical for our climate change solutions. It is vital for integrated energy systems in a carbon-neutral economy. By collaborating with industry, academia, and government, the national laboratories in the U.S. are accelerating the science that enables these solutions and other applications of nuclear energy. In the U.S., the Advanced Reactor Demonstration Program is one example of recent collaborations supporting this mission. Its goal is to help domestic private industry demonstrate advanced nuclear reactors in the U.S. It promotes advanced designs that will expand access to clean energy and significantly improve nuclear technology. And it leverages the unique expertise and facilities across the National Laboratory Complex to bring these systems to market. This program has three parts. First, demonstration, with the goal of testing, licensing, and building operational reactors within 5 to 7 years. Second is risk reduction to solve technical and regulatory challenges. And third is concept development that will mature additional technologies for demonstration by the mid-2030s. This well-funded initiative will help sustain nuclear power worldwide. There are many areas where the national laboratories contribute to pivotal discoveries in nuclear energy. Our R&D underlies innovations in every aspect of nuclear energy, and from reactor cores to the fuel cycle to advanced instrumentation, autonomous operation, monitoring, and control. Recent discoveries include new ways of creating advanced nuclear reactor designs that incorporate passive safety, reduce waste, and amplify the value of coupled energy generation technologies through integration. We also are innovating with energy storage and artificial intelligence and clearing the path for technology that we have yet to imagine in such areas as resilient and self-repairing energy storage technologies, the use of earth-abundant materials, and unique solutions tailored for diverse communities. With access to the powerful tools and user facilities at the U.S. National Laboratories, our innovators are able to make remarkable achievements. Our labs have resources that no single individual or corporation can assemble on their own. We have the capacity to do science at scale that empowers nuclear and other scientific breakthroughs of the future. Leveraging our world-class user facilities and deep expertise, we are developing new predictive computational tools for nuclear energy. These innovative resources enable designers and researchers to explore advanced technology options in practical ways. One example is the System Analysis Module, or SAM, reactor analysis code, which simulates entire nuclear power plants. It models all key aspects of the nuclear power plant, from the nuclear reactor to the coolant system to control and operator actions. It allows us to discover how systems within the nuclear power plant would interact with each other in event of a failure. The analysis significantly improves plant safety as a whole. Another example of our innovation is the GREET model, which simulates and measures emissions of vehicles, energy systems, and technologies. This helps us model the full life cycle of fossil fuels, renewable energy, and nuclear energy, from raw materials to engines to wheels and more. As an example, we're using the GREET model to identify opportunities and challenges of leveraging carbon-free nuclear energy to produce hydrogen. I'm pleased to report that our computing capabilities will be even more powerful soon as we bring on 3 exascale computers. That's a billion operations per second. The Frontier machine is already operational at Oak Ridge, while we will complete Aurora at Argonne and El Capitan at Lawrence Livermore this coming year. With high-performance computing, powered by artificial intelligence and machine learning, we will unlock new frontiers in science. These supercomputers will help us maximize reactor efficiencies. They will result in even faster and more cost-effective operations. Finally, the National Laboratories system supports multiple offices in DOE as it seeks to develop the next generation of energy professionals. For example, we help DOE benefit from university-led nuclear innovations, particularly through the Nuclear Energy University Program and Integrated Research Program. Our staff frequently engage universities and their students in various initiatives, as we will continue to prioritize our engagement with early career professionals and university students. The clean energy transition will require a broad array of professionals from multiple engineering, science, and technology disciplines. These future scientists and engineers will be instrumental to realizing our goal for next generation reactor designs, advanced nuclear energy systems, and clean energy integration. This is only a small sample of how the U.S. National Laboratories develop nuclear energy for a clean energy future. Shortly, my colleague, Dr. Martin Keller from the U.S. National Renewable Energy Laboratory, will speak to you of regarding some of the collaborations between renewable and nuclear energy professionals. They're identifying and amplifying potential synergies across these technology areas, and we certainly value their work. But now I'll turn things back over to James. Really appreciate it very much, James. Thanks for having me.
Thank you, Paul. What a wonderful way to give us some meaningful background and context to the conversation that we're now going to have. And despite myself coming from the UK's National Nuclear Laboratory, and our next speaker also coming from the NNL, and we're being hosted on the IAEA pavilion, this isn't a nuclear conversation. This is about how we collaborate across disciplines, across sectors as national laboratories. And so I'd like to invite Paul Nevitt from NNL to come and speak to us about the new Global Labs Alliance initiative that we started and tell us a little more about where we're going. Paul, over to you.
Talk on behalf of the Global National Laboratories Integrated Energy System Collaboration. So we had the idea at NNL during last year of the UK's presidency of COP. What could we do to have a lasting impact as a national laboratory? And we recognise the unique position that national laboratories have around the world in supporting the transition to low carbon technologies. And we recognise that we could bring together these laboratories in a way across technologies to integrate as a group of national laboratories to look at the energy system in a different way. So in January 2022, we brought together laboratories from the UK, the US, Canada, France and Japan across the energy sector, so nuclear, renewable and other low carbon technologies, to really agree to work together at this summit. And what we agreed was that, as I say, the unique position of national laboratories, us coming together could really help to accelerate the transition. And we identified 4 really key areas where we would agree to move forward and strengthen the collaboration and the role of national laboratories. One, as we'll get into as a panel, I'm sure, was around enabling technology demonstration, the ability to move from the technology readiness levels, taking ideas from the academic through industry deployment. There's a unique position for the scale of demonstration. Also working with end users and market assessment, the role we all recognized, and we're all working across hydrogen internationally and across boundaries. And then we all were operating country-specific models and generating case studies to support decision makers and policy makers, and recognize the ability to come together, to collaborate, to add real benefit. So when we talk about an integrated energy system, and there's a number of definitions, but in its simplest term, it's coming together in a fashion with those low carbon energy sources to optimize to have a low carbon, sustainable, low cost energy system that shows benefit for the citizens that we supply. In terms of that, what we've done this first year of working together and identified working up to COP27 is we brought together our thinking into a paper that is now available using the QR code to look at it, to get down what we see as those national laboratories as the key areas that we need to drive forward and work together. So those 7 key areas were identified, and I'll just talk briefly to kind of set up the discussion for others as we go through. So the first one is the focus on nuclear and renewable hybrid systems with energy storage. And despite huge progress in deployment of renewable and nuclear, over 60% of the global electricity generation still relies on unabated fossil fuels. We need substantial deployment of further renewable, nuclear, low carbon, and that needs to be in an integrated fashion. The second point leads on to needing to look beyond electricity. Yes, we electrify where we can, but electricity itself only makes up around 20% of global final energy consumption, and there are areas where when we can't electrify, how do we move to look to decarbonize those areas, such as using high temperature for industrial processes, shipping, aviation. There's a real opportunity, but the need for an integrated approach to where we electrify and where we use, for example, nuclear cogeneration to look to decarbonize those beyond electricity. One area that we've all been working on hard, and there's an example within the case studies in the paper that we've written, is to engage with the end users. So integration needs to be with an end result in mind, and that has to be driven by the end use. So early engagement and drive to ensure we're delivering what is needed from an end user. And as laboratories, we're again in a unique position to work with across those areas from an impartial perspective to bring together those end users. One of the areas noted when we look at the solutions is the integrated approach, not just across technologies, but spatial scales. We're working on national scale solutions, but also regional scales. Those have to be joined up in order to optimize both from an economic, but also to ensure we get the energy to where it needs to be on the timeframes that we're looking at. If we move through then to the next one in terms of taking an integrated approach at each stage, the system deployment and long-term planning, there's a number of case studies in the paper. We've got tools and systems that look again from multi-decadal system planning tools to looking at, as I say, the operational, how you would operate these integrated systems, including, as we move to the future, digital solutions and twinning, digital twin solutions to those energy systems. The next one is around, I talked about the role of labs in demonstration, and that's not just on the whole system level. It's recognizing that components as we go forward of those systems will be at different readiness levels, and it's recognizing that approach to how we bring those elements up. Examples include thermal storage, heat exchanger technology. How do we ensure that those individual parts are brought up on the timeframes we need to deploy them? And finally, it's a key element that there's a need and there's a real want for an economic assessment to understand what's the most economic and low-cost solution to going forward. But in some areas, we lack that data to feed the models and feed those decision makers. So there's a real role and recognition, again, from that impartial position of the national laboratories, to be able to provide that data to enable independent view, as I say, an impartial view, and provide that data to make that economic assessment and then feed that into develop. And we've got examples where we're working on what those new business models for those integrated energy systems will be. really pleased to be able to describe on behalf of partners. We've really made a step forward in the last 12 months in working together, and I'm looking forward to both taking forward that collaboration, expanding it, and seeing to have impact. But I'll hand back to James now to feed and discuss with partners, and look forward to taking this discussion further.
Thank you. I think we're sharing one microphone between us, chaps. Oh, is there another one at the other? Okay, good. All right, there's one at that end. Excellent. Thank you very much, Paul. Absolutely fantastic. Another to set the scene for the conversation that we're gonna have now. Martin Keller, if I might turn to you first. You're the lab director for the National Renewable Energy Laboratory in the US. From your perspective, what do you think is the most important factor when we thinking around integration of the work that national labs are doing and the importance of collaboration between us? How important do you think it is?
So, okay, first of all, thank you for having me here. So, look, I think that the collaboration across the laboratories, also across different countries, is extremely important. When we was talk about this, what we have to do to really decarbonize our economy, if we want to go to 2050, you know that we have only about 10 years to develop the technologies before we then can start to implement this. So this is a problem, in my opinion, which is bigger than any laboratory. It's bigger than any country. It's bigger and really scary to do this across the whole globe. So we definitely need the collaboration across everybody to bring everybody along. I also want to perhaps at this point make this point about the systems integration approach. So where we're going on the global energy demands, I think globally have seen, we know a good path towards electrification. We know what we need to do there. But then overlay this with the whole transportation sector, which will electrify to a big degree. But then we also have a lot of other areas like industry, cement, steel, name it, heavy-duty transportation, where we need to look at the whole systems approach. And again, this is what this kind of collaboration across the laboratories is doing very, very well, and I think it's extremely important that we need to see, and thinking beyond an electron, we need to look into this to see we will need to produce hydrocarbons. Can we use this and use e-fuels? And you also have a statement here in your paper. Hydrogen as a platform molecule is extremely important, where you could see a beautiful synergy between nuclear and renewables to go towards hydrogen using process heat coming from nuclear. So, but again, we have historically not done too much work on the full systems integration, because historically we had these pillars of energy use, and now this is changing. That's why I think this deep collaboration across our borders, our countries, across all the different laboratories is so critical.
Thank you very much. Jonathan Cobb from the World Nuclear Association. If I might turn to you, you bring a slightly different perspective, perhaps reflecting where better integration, better collaboration between national laboratories can support the wider industry, wider nuclear industry. I wonder if you could sort of share some reflections on how you think that better integration could support the private sector and what they're trying to achieve.
Well, I think number one would be the commercial aspect. If we want to understand more about what our future may bring, we need more accuracy in what we have, and therefore any improvements we can make in the process of bringing models together, integrating across the different types of generation, integrating across different geographies, that can help give a clearer picture, which can give more certainty to business. It removes some of the risks for business to have an idea of the world that is going to be ahead and the world in which they are going to be seeking to operate. I think also there is a lot of interest in getting better modeling, better integrated models, because of the deficits of some models that there are at the present, especially because of the importance that these models have. They're not academic processes which don't have impacts. They are paid a lot of attention by decision makers, and those decision makers will see the results. They may not necessarily interpret the results, they see the results and act on them. And therefore it's vitally important that these models are good and that they are giving the right information to policymakers to enable them to make the right policy decisions. And unfortunately we have seen some examples of integrated assessment models done in the past where there are, on nuclear in particular, very arbitrary constraints put in early on, and then the models are built up and they're very complex and they come out with an answer and they don't necessarily fully incorporate all the possibilities that nuclear could have. And so that's what I like to see, to have more, have a good model based on sound science, based on a fact base, acknowledging that you can have a set of facts that support an opinion. So really, the idea of making it more geographically diverse, having more parties involved, is going to increase the likelihood that any particular bias is going to be removed. So I think that's an excellent thing. And ultimately, one thing I'd like to see and comment straight away is I've seen reference in this to nuclear hybrid systems, in a way that implies right from the start a tribalism that we have in energy, that we mark out nuclear and then we bracket together renewables. And you've got wind, biodiesel, you've got solar, you've got hydro. You can say hydro and nuclear are more similar in many ways than other low carbon energy sources. So I'd like to see this referred to as an integrated clean energy system rather than it being a nuclear renewable hybrid. That would be my suggestion in terms of enabling better communication to policymakers.
Thank you. I suspect we may return to that theme of communication and the communicating the work of the labs, particularly as we seek to collaborate better together. But Paul Kearns, if I can turn to you and ask for your reflections on the importance of collaboration, and perhaps given your role as a lab director, your sense of what good collaboration looks like and what the hallmarks of effective collaboration are.
Thank you for the question, James. Happy to add a few thoughts. First of all, much of the science we do today is team science, and certainly the topic of integrated energy systems is really something that requires quite a bit of scale in terms of our thinking, our approach, and really just integration of disciplines across many fields, as I mentioned earlier. And so it's essential in this regard. I think one thing that also is critically important is having a diversity of perspectives that really allow us to understand what might be the appropriate solution for any given community or any given geographical area. And so I think that's really essential. In terms of what a good partnership looks like, I think there are many great examples. I might call on my colleague from the U.S., Martin, to talk a little bit about a partnership that he actually started at COP27 just last year, associated with the Net Zero World Initiative, where he's brought together very effectively 10 of the U.S. national laboratories to really work with the Department of Energy and the State Department, and 6 partner countries. I guess we just expanded that to 7 or 8 partner countries with announcements today, but really just an excellent example where we've kind of set aside, if you will, our individual brands, and we're really focused on the larger overall objective in terms of making a difference across the world in terms of our ability collectively as society to meet the decarbonization objectives that we've all established. So I'd pass it to Martin for a comment or two about Net Zero World and how that partnership model works, if you don't mind, Martin.
Yeah, so Paul, the Net Zero World collaboration, I think, is a very, very interesting construct, which is now 10 U.S. Department of Energy laboratories working together with the countries, where you then help them to develop this implementation plan, how to achieve their transition to clean energy. So it is based on very hardcore systems models to then lead to implementation. We at NNL, we started this program at Los Angeles, where LA came to us and asked us, what will it take to go for LA 100% renewable energy, which then leads to this very deep modeling where we modeled every transmission line, every charging station in the future, every rooftop for solar panels where you could put wind, which then leads to the deployment plan for Los Angeles. This was then copied for the Net Zero World to do this very specifically with the individual countries to help them to create this transition plan. And Paul mentioned this, I think what's very unique, because you really custom work with the countries, where you give the countries the opportunity that you not come and implement, well, this is your goal. The goal is set by the countries, and you just do this deep kind of system understanding with the modeling and implementation to help the countries to achieve and get a blueprint how they can achieve their plan. I think this is also very important, now coming full circle back to the whole system, because every country is different. Some of our partner countries have a lot of nuclear where they want to have integrated. Other countries say, well, we don't want to do nuclear, we want to do, they have enough hydro, for example. So this is again where every country is unique and specifically different. But the key is really to do the full modeling of the systems, because this is key that when you decarbonize this, it's not just electricity generation, it has to be holistically the whole model.
No, thank you for showing those reflections. And Paul, Paul Nevitt, you were at the start of this Global Labs Alliance concept, and hearing about the net zero world construct in the States. When you started reaching out to other organisations with the idea of wanting to connect us better and work together with this common aim of having a better integrated energy systems set of modelling and approach, what kind of response did you get? What was the sentiment there? And what are your sort of thoughts on expanding the alliance even further?
Yeah, it's interesting because we started and there was real trepidation in terms of you never know when you make that call because you work with the other labs across the world, and particularly you tend to work with the same one. We have great relationship as the UK's National Nuclear Laboratory with a number of the US laboratories in the nuclear space, but broadening out that collaboration, we were uncertain of what reaction we had, and what reaction we had was a really positive one. And actually, the recognition, and again, one of the things I think we've said, I think Paul said about diversity of thought, there is a recognition, particularly within the national laboratories, of that need for the systems approach, because I think we're made of individuals and scientists, engineers, artists that look at a problem in a different way, and we tend to take a step back. And when you look at the problem, it all comes back to you need a systems approach. You can't work in isolation, and that drives you to collaborate. So we reached out, and we were clear that we didn't want it just to be another nuclear collaboration. It had to be across the labs working in the energy space. So in the UK, we reached out to the Catapult network in the UK, which is the equivalent within the UK, as well as the national labs, and we work with the Energy Systems Catapult. And then in the US, again, with NREL, and in France, again, examples of they've collaborated and brought together the nuclear and renewable into one laboratory, recognizing the approach. So there's examples as we go forward. Looking forward, we actually discussed at the last steering group meeting at the laboratories recognition that we need to broaden this out. Because there's a lot of both learning, and as you go to deployment, you need to have that wider connection. And there are, from a practical sense, we wanted in the first year to embed a collaboration with a manageable amount of laboratories. So 10 was seen as about manageable to lead. But as we go forward, I think we all recognize we need to broaden that out, both to other nations and to wider laboratories within nation. So that's what we'll look to do as we go forward.
Thank you. And I'd like to pick up on the comment, Jonathan, that you made around tribalism and around the words that you use, and perhaps ask you to comment first, and then perhaps turn to Martin, because one of the reflections I think I have about the nuclear industry is it's done a fantastic job of talking to itself for a very long time, but an absolutely terrible job of talking to other people. And one of the reasons I'm so excited about this as a construct is it's the nuclear industry deliberately wanting to reach out and connect with other energy vectors, other disciplines to really play its part in that clean energy system, and rather than, as you say, a sort of portmanteau of nuclear and some other thing, and it creates a sort of strange hybrid world. I'd be interested in your thoughts on where you think sort of nuclear's head is at when it comes to collaborating with other sectors. And then perhaps, Martin, after Jonathan's commented, I'd be interested in your reflections on the renewable industry's willingness to connect with nuclear. Clearly, NREL has wanted to sort of clasp an open hand, but how might you characterise that relationship more broadly? But Jonathan, if you could comment first.
Sure, I think that's true. I think that we have been talking to ourselves within the nuclear industry. I don't think that's necessarily out of want. We have been trying to reach out, and I have to say, I think in the last year or two there has been more openness from other low carbon technologies, from renewable technologies to start that dialogue. But what I hope is that from this collaboration we're seeing today between renewables and nuclear at the national lab level, perhaps that could form a way of introducing the industries that are working with national labs onto like a one-to-one basis, bring them together as part of that collaboration, so broadening the range. So that could be a useful way of doing that. I would just say there is another side to that when you look at industry. Many of the industries that are involved in nuclear generation are involved in all forms of energy generation. They are already a broad portfolio of different businesses. So they're doing fossil fuels, they're doing nuclear, they're doing wind, solar, the whole lot. So there is, at the company level, already a very large amount of discussion, because they're the same company and they're trying to work out where they should be putting their investment, what should they be developing next. So maybe it's not so much the industry and the companies, maybe it's down to the trade associations, are the ones where you are often called the Nuclear Trade Association, the Hydro Trade Association. We're the ones that need to stop being so shy and get out there and start mixing more.
So, well, with the danger that for me, not being a nuclear person, stepping in somebody's backyard there right now for a second, but I tell you I think there's a big issue, because I think when you look at this on different countries, nuclear is seen as, for many people, as kind of black and white. You love it or you hate it. You wouldn't touch it, or you say, of course. And I think what the problem is there, that in my opinion, on a global scale, there's in a positive way, a race going on to see that we electrify as much as we can, and then there is something which we cannot decarbonize, where we need a kind of energy molecule. And then the question is, frankly, I think this will not be electricity, it will be something else. So what could this be? It's ammonia, it might be hydrogen directly, it might be methanol, it might be electrofuels. So there will be a molecule which will be shipped around the globe. I think that's pretty clearly that this is coming. And then there, I think the key is, what will nuclear play in this kind of integrated system? It frankly always comes down to cost, where I think we're nuclear right now in the electricity sector, can make a big play, but then you're hearing this when you combine, let's say, renewables with long duration storage, which might be hydrogen or which might be some other molecule. When you see what's going on in the MENA region, here, or in certain areas like Patagonia, where you're reaching electricity costs from a cent a kilowatt hour. So the key is, what frankly I always argue, what will nuclear do with small modular reactors? What is the cost which nuclear can achieve? And then frankly also, how can this be integrated in the production of the fuel molecule we ship around? And I think this is, in my opinion, what from my view, again from an outsider, what I've not heard so much is that how nuclear position itself to be more than producing electricity. And I think this is a key, because when you go for, let's say, high temperature electrolysis to go to hydrogen, very, very exciting technology. But I think from an outsider spoken, I don't see, so it's picking up, which is really cool. But I think from a industry perspective, I'm not hearing so much from the nuclear side as you're hearing from the renewable side. But I think the key is, we need a lot of clean electricity production if we take this electricity to other energy molecules. So nuclear will have to play a very important role. But for me, from the outside, it's not clear what this role will be, to be very honest, because everybody hopes for SMRs to be the breakthrough and really bring down the cost, but I haven't seen it.
And I think that's a fair challenge, Martin, and particularly thinking about how we as an industry communicate. The very premise of advanced nuclear, the so-called Generation 4 nuclear reactors, are absolutely around the heat they generate and the potential of what you can do with that heat. It's less about the electrons they produce. But what's interesting, what you've said, is that is not being heard and understood outside the industry, which goes back to the challenge, I think, of how we communicate. Paul, Neve, if I could turn to you and think about pace. We are at COP27. We are keenly aware of running out of time. for to decarbonise the world. Getting collaborations to work effectively can take time. Integrating complex modelling, like energy systems modelling, is difficult. How do you think we can do this at pace so that it can hit the desks of the policymakers, as Jonathan was describing, to inform decisions in a timely enough way, whilst at the same time recognising that it doesn't happen overnight? How pacey do you think we can be? How pacey do you think we need to be in terms of this better integration of the way the labs are working?
Yeah, I think acceleration is really important. And I think, as I say, I go back to, I think national laboratories fill a unique role. And as governments look to accelerate, I know in a UK context, the UK government are reviewing how they use their national laboratories in that space to accelerate the demonstration of technologies. Because to pick up on Martin's point, in order to make some decisions, you need an evidence base. And in order to generate that evidence base, you need to demonstrate. So, our SMRs is an integrated system of low cost. We need to demonstrate that. And that means accelerating that demonstration deployment. And for me, that's where the unique position from a government perspective of a national laboratory is that you can accelerate using that network to produce that independent evidence base in order to make your decisions for the system. And that, to me, then is, we see an acceleration, and we did an assessment a couple of years ago now of how you accelerate, in this case, advanced nuclear. And one of the biggest ways of accelerating is to give the pace at which you get to a decision. So it's not actually to do with technology, it's the pace you can take. Can you take out the timeline to a decision? And so if we can provide that evidence base, decisions can be made quicker from an informed position, and that's where I think you'll see the acceleration and the role of the laboratories.
Thank you. And Paul Kearns, if I turn to you, thinking about that acceleration imperative, what are the sort of things from your experience that slow us down? What's going to hold us back, do you think, if we aspire to accelerate together and collaborate? What will hold us back? What barriers do we need to overcome?
Thank you for the question. I think there are a number of factors, and one is just not having a common objective, not having consensus really as to the target that we're trying to achieve, I think is really can slow things down and really make progress very difficult to accomplish. And so I think that's key to start with. So dialogues such as this one really help to bring people together and help them develop a common mindset in terms of overall objectives. I think also, I want to go back to the Advanced Reactor Demonstration Program that the U.S. has established, where we've set a very aggressive goal, really to demonstrate advanced technologies in 5 to 7 years. So having something that is seen as a challenge, I think, is healthy as well, and also yet fairly focused. There are 2 reactor types that have been selected: sodium fast reactor with energy storage, and then high temperature gas reactor. Both of which have selected sites, and they're moving forward. The national laboratories are leaning in fully with our capabilities and really to make things happen. Big challenge, I think, for both of these advanced reactors in the U.S. will be the regulatory framework that they'll have to pass through, basically, to actually get the authority to begin construction, and so that's key. The laboratories can lean in extensively, I think, to Paul Nevitt's point in terms of really evidence base, really in a couple areas. And one is reactor design, just really moving forward and advancing that. And the second really is the safety basis that accompanies that reactor design to make sure that it's bulletproof. It's got to be. We can't afford a misstep, and so that's really key in my mind. So I could go on, but I should probably let you take the conversation back over, James.
No, thank you very much. And I love that, the importance of a common objective, something that we can charge hard at together. And Paul, if I perhaps place the last question on you as we close out here and have run out of time, what do you think? What ideas do you think we might be? What can we charge hard at together? And what can we expect to see next? Do you think from the Global Labs Alliance?
Yeah, so we've identified, three key areas. Understand the end user, what's the role of hydrogen, and then underpin that with the evidence for models. And that's the 3 key areas that we identified where we could genuinely collaborate to drive forward. And as I say, to underpin that with real demonstration gives us the evidence base to really support that acceleration towards that joint objective. So that would be my summary to take forward.
Excellent. Thank you very much for that. All that remains for me to do is to thank you very much, gentlemen, for that very interesting and compelling conversation, and to thank you for the work you are doing to create this collaboration. I absolutely agree that we will do this faster if we do it together. And thank you for your commitment in taking this forward. And thank you to everybody else for joining us today. I hope you found that interesting. And that's us. Thank you.